AI is everywhere. It's transforming the way we live, work, and interact. It writes our email, it answers medical questions, recommends what we watch, and even drives our car. But here is the puzzle. How can we be sure if these systems are really good, trustworthy, and safe? We have been measuring AI intelligence with numbers, with different scores, like accuracy, F1 precision recall, and with some benchmarks and leaderboards like this. You see big tables whenever there is new release, and sometimes with costly human evaluations. So people are commenting that this version of GPT is better than that one, and blah, blah. So the problem is that we're trying to build systems that are getting more complex and complex, and these types of measurement, it cannot capture the essence of this task. So today, I want to explore a bold new idea. What if AI itself could judge AI? So here is the theme of my talk: evaluating AI with AI, LLMs in benchmarking pipeline. So in this talk, I will show you why this matters today and try to give some scenarios, and then we'll do a live demo together. As you have already heard from previous speakers, evaluation is a really great challenge in AI today. So we had traditional methods, we have been evaluating them, but these methods were often slow, rigid, and they were shallow. They were designed for specific task, specific purpose. For examples, we use numbers like accuracy and metrics like rouge, blue. So they have their own essence, but they don't always capture creativity, nuisance, or true quality of the task that we want. On the other hand, we have been using human annotators. So there have been crowdsourcing platforms that let us do this. So we put some tasks, and people come over and they judge the quality of output. But it is very expensive, time-consuming, and it is very difficult to scale. So if you build a model, and if you do a small tweak, you have to do it from start. So that's not a good way to do. So we have some benchmarks. There are like different benchmarks that we saw in previous slides. So they are designed for specific task, very narrow task, and they don't transfer well. So if you want to evaluate our new task, it doesn't work correctly. So it doesn't work for new task if you want to test something new. So in short, we're trying to measure very complex intelligence with very simple rulers like this. So there is some problem going on here. And the good thing is that we have a new savior, ChatGPT, Gemini, LLMs. So here is the idea. We use this new thing, large language model, or LLMs, as judges. The good thing is that they are already trained on huge corpus, huge amount of information, huge knowledge, and they can reason across different tasks. They can have different domain knowledge, and they can easily adapt to these tasks and different rubrics. So the process is simple. We give LLM the original prompt or the output we want to evaluate, and ask us to give us clear assessment criteria based on the rubric or criteria that we want, just like a human expert would do. So this opens a new way of thinking about evaluation. Why this is exciting today? Because LLM just give us 4 superpowers. So you can add more, but I will talk about 4 here. The first one is speed and scale. So we'll also see in demo that we can run like thousands of evaluation in minutes. So it is very easy to scale. So for example, if you want to crowdsource, it is impossible to scale, but this way it is very easy. And the second one is cost effectiveness. So it reduces the dependency on human annotators or evaluators, so the cost would be very low. The third is flexibility. If you want to test on different criteria, for example, if you want to test on accuracy or empathy or legal risk or, for example, tone, you can just change the rubric or criteria or the prompt that you give to LLM judge, and it will do it for you. And the final one is rich feedback. Because large language models, they speak our language. So they can give us feedback in natural way of speaking, that is our language. So we have been using some other way, for example, classifiers to do the same task in the past. They gives us yes or no output, but this way, this AI judges can explain why it came up to that conclusion, although it might not be logical, as we saw in the previous slides, but like it will give us some explanations that sounds a bit plausible. So we can get deeper insight, and we can probe about the model performance, so it can be a bit meaningful. Now, we're going to see some scenario where this AI judge can be useful. So the first one, I want to make it very generic so that all of you can relate with what you guys do. So it is one open-ended task. For example, imagine that we have some chatbot in our website. So people are interacting there. So we have some data set collected from there, and we want to evaluate what is the quality of that chatbot. So we have 4 metrics here. For example, empathy, correctness, clarity, and safety. So if you want to evaluate a data set about complaints or like about conversations there, so it will be very difficult for humans to just see at each conversation and rank this. And it is very slow, and also it is very subjective. So there can be different human annotators. They can have their own biases, and they can rate with their own values there. But if we give this to LLM, the scores and explanation can be consistent. And it is like having an expert teacher that can grade thousands of papers instantly and consistently. So we'll see this in example. So this is one very generic scenario where we can use LLM as judge. So here are some rubrics that we can use to give it to LLMs. For example, if you want to clarify what empathy means, so we can see that, okay, these are the scores range. For example, it is from 1 to 5. So what empathy means to us, so what we want it to judge, we can clearly define it in a textual way. So here it is in table, but we can translate it into text. So we can have a very clear rubric or criteria that we can pass to LLM. So this is the benefit of using LLM here. Now I want to add another scenario. So we are getting new models releases from companies. So it's a kind of competition. So they come up with new models. And we have seen that new models aren't always better. So in this scenario, we are trying to compare 2 models. So for example, we are using these models for chatbots in our websites or in our services. Then how do we make sure that new models are better? So to do that, traditionally, we do something called A/B testing. So it is very popular in software practices. So we release this new model to a set of users and receive their feedback. So if they say, okay, it is better, and the responses are better than the previous version, then we think that, okay, it is better, so it is good for release. So it is in the software release cycle. But it takes time, because we have to wait for feedback from users, and we have to quantify the outcome of that A/B test. But instead of that, we can use AI just to do this. So AI just can do the same thing that AI just can simulate the scenario, and it can figure out which models was better. So it gives us answer as well as the reasoning why it has been better. So what are the criteria that it has improved, or what quality has degraded from the previous model. So it can be used there. So it makes us faster to identify the stronger model for our task. So this is a scenario where LLM just can be used. And another use case is safety testing. It is also called red teaming. So whenever we build a model, nowadays these models are a bit aware, but in the previous scenario, it was very easy to jailbreak this kind of model. So we make some applications with our LLMs. So people would, try to break the models. So they will ask nonsense questions, and they will try to make the model violent. So if we have to check this manually, it would be a very difficult task. So traditionally, experts do this manually. So they try to prompt, and they try to break the model. And it is manually, it is only possible to cover a very subset of probable cases. But with LLM Judge, we can generate thousands of adversarial prompts and check the responses. So Judge can flag harmful or stereotypes or misinformation or unsafe advice that the model can give. So this makes red teaming practical, systematic, and scalable. So these are some cases where LLM Judge can be used. Now, let's see how the process is. So how can we deploy this LLM Judge? So it is, in simple, it is just 3 steps. In the first step, we gather the output that we want to evaluate. For example, if you want to judge AI, then these outputs are from AI. So you gather them. So it can be from different scenarios. Then you define a clear rubric. So rubric is the criteria that you want, that is a set of rules that you want to use for evaluation. So you give that prompt to AI, so to LLM JAWS. So you say that, okay, these are the rules that you use for evaluation, and these are the output from LLM for this input. So it's kind of textual prompt. Then the third step is evaluation. Then after the prompting, the model will give us some output. So it will say, okay, I think like the score should be like this for this particular example. And we have to use some parser to get some number from there if you want to use it in scale. So the judge will return a structured score and some explanation. So we can prompt it to do that. So that's what we're going to see in the pipeline that we're going to do in demo. So we'll see it. And we have already heard that there are lots of pitfalls of using this idea. Of course, it isn't magic. So they have their own limitation. For the first example, the first practical limitation that we have been seeing is LLM bias. So it has been seen that LLMs are biased towards their own output. For example, if you judge output from GPT-4, and if you use GPT-4 as JAWS, then it will bias its own output. For example, if there is GPT, let's say like Grok output and GPT output, it will prefer GPT output and give higher score. So this has been seen consistently. So to resolve this, like we might want to resort like using different model for using LLM as JAWS. And second one is positional bias. So this is also a very important one. For example, if you have like multiple choice questions, and if you have them in order, for example, 1, 2, 3, 4, models will pick the options in the front. So this has been there, and the solution to this is like we randomize the positions and we try it again and again, so we can reduce this positional bias. And the third one is rubric quality. Also, we can say like it's kind of prompt engineering. So we have to make sure that we give proper instructions to this LLM JAWS. So a single sentence can have multiple meaning. So it should be very clear, and it should be very, it should have high quality. If there is like some difficulty for model to understand, or even like some small variations, it can produce different output. We'll also see this in example, but this is very, it's kind of pitfall of this kind of method. So it depends on rubric. So if you have a small change, if you just tweak rubric a bit, the output will be very different. And a very important thing is that it cannot replace human. So they are powerful, but they can complement, but never replace human oversight. So it will help us in lots of cases. So it can give us to derive like the quality of the method that we are using, quality of models that is there in the production. But until now, like it seems like it's only augmenting human oversight. So yeah, they are evolving over time. So we'll see. Now we're gonna dive into the tutorial. So in the demo, I will show you how to create an evaluation pipeline. So we'll load a model as our judge. So I will use one of the popular architecture. Then we will create a rubric. Rubric is the scoring criteria. So what we want from that model, what we want from that judge. So what is the range of the score? So we have to make it clear. And we will ask you to evaluate other models' output. So we'll make a small data set and situation here. And we'll look at the structured feedback. So we'll see like what models output and how they score. So what is the way they score. And at the end, we'll have a blueprint for using AI in different applications, whether that's healthcare, finance, law, or something else. So it's kind of generic application. So let's get started. So this is the setting here. I think it correlates with the previous speakers. So Vlad was showing something similar. So he was showing a similar scenario in generation. So it is a data set called feedback QA, and it contains interactive feedback from users. So for example, like it's a like question answer data set. So it's a very generic example. This can be multimodal as well. There could have been some images as well, but like I want to simplify the scenario. So for example, there is a user. So you'll be asking some questions. For example, like how do I get help finding a job? So that's a question. And there is some RQA system. So it is a system from this paper, from the same paper where they have this data set. So it's kind of, let's say, like visual, it's kind of like question answering system. So you'll have a question, you want that AI system to answer something. So it will come up with some answer there. So this is the output from that RQA system, from that AI system. So this is what you have. And on top of this, you have 2 human evaluators. For each question and an answer, there are two people, they are independent and they are evaluating the answers. So for example, like let's look at that sad guy. He looks really sad. So he read the answer and he figured out that it is not relevant for him. So definitely it is subjective. So he scores it 1 and his feedback is there. He writes like 1 or 2 lines there. So there is another guy here. He looks happy. He read the answer. So for him, it is like a bit, he finds it helpful. So he gives his score 3. So we can see that like the same answer can have different meaning to different people here. So we'll also see this in the data set. And he also writes a couple of lines. So this is the structure that we have in our data set. So a single question, a single answer, and 2 scores and feedbacks. And we have this rubric here. So they will also, they score, like they actually like write one of these 4 options. But we translate it into score 1, 2, 3, 4, so that it's easy for us to calculate statistics numerically. So this is the setup. Okay, let me get into my course here. I will try to mirror my display. Let's see. It's working good. Okay. Okay, I don't want to get into jargons here, so let's run this up. Yeah. Okay, we'll start from here. So this is the same thing that we saw previously. So there is one question, there is one answer, and for this set, there are 2 sets of feedbacks and score. So this is from evaluator 1 feedback, and this score 1 is from evaluator 1. So feedback 2 is from 2, and score 2 is from like evaluator 2. So this is the thing that I showed you in the slide, and we're going to use this, and we're going to replace the human evaluators. Instead of using humans there, we are going to use the LLM judge and see like how they are helpful. Will they be able to perform similarly to these human evaluators? So this is the goal here. So let's begin. So first of all, we clearly saw that there are differences in evaluations. So we want to see the correlations between 2 scores. So are they, how correlated they are, how correlated they would be. So let's run this one. Oh my God. Yeah, so this is the correlation between 2 main raters. So on the, okay, this one. On the y-axis, there is rater 1, and on the x-axis, there is rater 2. So the correlation is like 0.56. So we have to keep this number in mind. So this is our base. So we're going to compare the result of LLM with this one. So okay, given that 2 experts, they correlate between their judgment by 0.56 numerically. So we can see that like they are like if rater 1 say bad, the rater 2 also say almost bad. Like and if it is excellent, the rater 2 is also saying excellent. So it is like, you know, in this confusion matrix, it is seen that they almost like agree in edge cases, but like in the middle, they don't agree much. So yeah, it can definitely be vary, because you can think that it can be improved a lot, and sometimes like the other one could think that okay, it is acceptable, but yeah, I don't like it, so you might give lower score. So this is the scenario that it is here. Now. Okay, let me see like how many. Okay, we have like 5,660 rows here. So this is pretty like that's a lot of samples there. So we'll try to only select the numbers where the evaluators have same score. So here, like I'm trying to select just for simplicity. So we'll do some examples here. We'll do some tweaks in prompt. So I want to like make a small set. So we'll again go back to the bigger one. But here I'm selecting the examples where the human raters agree. So the scores are similar, as you can see here. Both scores are same here, like for all the range, like 1 to 4. Now, the correlation between 2 raters should be 1, because we have just selecting the cases where both raters agree. So this is the scenario. Now we're going to create our LLM judge. So here, I'm using one of the model that is hosted at our EX3 data center in Simula. It's in our basement. So I'm using one A100 GPU, and I'm using a VLLM inference engine there. So it uses flash attention, so it's very optimized for inference. So we'll see the performance later, but this is the model that is loaded there. It's like Coin 2.5, 7 billion in stock model. And I'm going to, like, I have this API, I have routed this to that server, and like, you know, I can call this. For example, like if I ask some question here, it will be able to answer. For example, I can ask like, what is so special about Domus? Like it's gonna answer me like, what is so special about, let's ask something else. So let's ask Norway. So Yeah, if you ask something, so like the question will go to the server through this tunnel, and like it will answer here. So yeah, it is it. So yeah, this is the setup. So instead of this model, you can use whatever you like. So this is inference client. It's a library from Hugging Face, but you can plug in like Gemini or like whatever you have, OpenAI compatible servers, or even like OpenAI APIs. So this is so I think like if you are using like LLMs APIs, so this method should be fairly common to you guys. So yeah, this is the setup for model. Now we're gonna make a JAWS prompt. So I have loaded it here. I don't know if you can see it properly, but okay, yeah. So it's a simple JAWS prompt. So we have the scenario here. Okay, let me try to make it more visible. Yeah, there should be some setting, theme, okay. Light theme should be better. Yeah, looks so. Yeah, okay. So in the JAWS prompt, we are saying to LLM that, okay, you will be given a question and an answer from system. So your task is to provide a rating. So it's a very simple setup. So we want a number. It could be float, and it should be between 1 and 4. So like 1 means it is not helpful at all, and 4 means like, okay, it is helpful. So we want to, this is how we give it to LLM, and we provide 2 variables here. So 2 variables, one is question and one is answer. So we know that from the beginning, we know like what is the question and answer. So this is the prompt that we are giving to LLM via API. So imagine like we are writing this in ChatGPT, so we just write this scenario and like we just give an answer. So we want some answers from ChatGPT or like this LLM. So it will give us some number. So we are asking it to give total rating variable here. So it will give a number. It's between 1 and 4. So we are asking float value. So we hope like it will give us. So let's run this. So here I'm just using this progress apply from pandas. So it's gonna run in loop. So for each item in this in this data frame, so it's gonna run this LLM calling here. So let's call this. Okay, did we got some? Okay, just a bit. Okay, I need to run this before then. Yeah, so okay, look at the speed. So we are getting like 2 iterations, like 1 iteration per second. So yeah, it's because of LLM inference engine. So it is calling the API, it's happening very fast. So within almost like 13 seconds, it was able to just 28 output. So now we're gonna extract the score, because the LLM will give us textual output. So we have to extract the number from there. So I will show you like how that was done. So let's see here. So this was our question, and this was our answer. This was feedback 1 from the user. So let's go to the LLM JAWS output. So last 2-1. So it is giving in the required format. So we asked it to give total rating in this format, and then it will give explanation here. So from here we parse the score that was given by LLM. So we had a function here to extract JAWS score. So it's a very simple rule from this library. So we are trying to parse the digit that was in the beginning. So it was 2.5. So it was rounded over to 2. So yeah, that's how we come up with like this parsing system. So yeah, this is the score from LLM. Like if you give it to ChatGPT, it will give similar score. So because we prompted to give it in a particular format. So yeah, it will give total rating, some number, and in the new line it will give explanation. That was what prompted. That was prompted in the prompted here. So yeah, it was like provide your feedback as follows: feedback and your total rating. So this was the format requested, and that's how it gave us. Now let's see the correlation between LLM as JAWS and human raters. So here. In the x-axis, we have human scores, and in the y-axis, we have like LLM JAWS score. And the numbers of the filter example that has like same human scores were very low. So like you can see that it is correlating pretty well. The correlation number is like 70, although it is like small set where the humans agreed on the judgment. So it can be seen that the scores from LLM and the scores from human raters, they are almost they are good. They are in good correlation. Yeah, there are edge cases. For example, like when humans were saying it was bad, LLM just says like it is, it could be improved, and it gave 2. So like there have been some differences, but as you can see, like in this diagonal side, so it is 0. That means like there was no very serious misclassification. For example, if it was bad, like the model didn't say it was excellent. So there have been like few variations in the output from LLM, but it correlated very well. So if you remember the correlation, it was around like 0.53, but the correlations between LLM and as judge and human raters was 0.70. So that's a big difference here. So also not to forget that this particular experiment was done in a very small subset where 2 human raters agreed. So like the examples, it is not like whole set like 5600, but it is a very small subset. So we're going to do it on a whole set. So now we're trying to improve the LLM judge. So it should be like we should be able to get more than this. It can be possible. So I want to show you the prompt here. It was very simple setup. So like we just asked for a number between 1 and 4, but we didn't say like what is the variations between like 1 and 4. We say like 1 is the worst one and 4 is the best one, but we can do more. So that is where the rubrics come in. So rubrics are the way we want LLMs to score. So we can clarify this a bit more. For example, like here I have clarified like how the scale should be. For example, 1 is the case where answer is terrible, and 4 is the case where the answer is excellent. But also in between, like 2 is the case where answer is mostly helpful, and 3 is the case where it is 2 is the case where it is mostly not helpful, and 3 is the case where it is mostly helpful. So it is just a bit of tweaking in the prompt. So we want to add rubric here to make sure that LLM is very consistent, and it is also giving the similar answer. And this rubric has also been derived from the way humans score. So this rubric, like humans, when we ask humans to judge, we gave this rubric to them so that they saw this rubric. So they chose like 1 to 4 from this rubric. So we use the same here, and we're gonna ask LLM to do the inference in this case. So yeah, it's gonna take like a couple of seconds. So okay, here are 28 examples. So out of 5600. So let's see with the improved prompt, a bit of tweaking with the rubric. Now, okay, now we can see that the correlation increased from 0.70 to 0.74. So it's a good improvement. So this means like if you improve prompt a bit, if you make it clear, so we can get higher score. So the rubric should be very clear. Let me try to. Okay, let's do this. Like, let's try to change a bit, and let's try to see like what happens. I was trying to do some prompt engineering using ChatGPT. So let me see if I can get it here. Okay, here. So I used ChatGPT to optimize the prompt. So it is very easy. So I just say that okay, this is the prompt that I have. I just copied from there, and I just said like optimize prompt, make it clear, and it gave this one. So as you can see that the prompt I gave was quite longer. But like ChatGPT gave a bit shorter prompt. It is like very clear, precise, I guess. So let's check with this one. Yeah. Yeah, also like the older prompt that I had here. So this was I took this I modified this notebook from Hugging Face cookbook. So I just used the same prompt they used, and they were using Mistral for evaluation. So I just copied that one. So it has been seen that the same prompt won't work for all the models. So you have to do a bit of tweaking. So that's what I'm trying to do it here. So this is the one optimized by ChatGPT. So I have not tried it yet. So let's try and see what happens. So let's remember the score. It was 0.46. So let's do inference again. Yeah, I'm pretty sure like it is clear. Yeah, because there were a lot of redundant things here. For example, like we were writing the system answer is mostly, it's like system answer is repeated in all the cases, so it is redundant. So like there is no any information here. So I think it cleared that part. So okay, then now okay, it's done. And did it run properly? Okay. I didn't run this one then. This one. It should improve a bit, or maybe degrade. Let's see. And oh, it's the same. Let me see if this is a mistake. Oh, okay. Improve just prompt. Proofs as prompt. Oh yeah, this is. I think I did it, didn't I? Yeah. Let me see. Something is happening here. Okay, this one. Okay, it was very similar. Let me see. There's something is going wrong then. Should work. Yeah. Okay, it didn't change then. Yeah, it might be the same cases. Here, okay, it was this one. Okay, this is run. This is run 0.7. Okay, let me. It can be so coincident that like changing prompt, it shouldn't be giving the same answer. It should be something different, but it might be the same as well. But like, let's see. I hope it should change because yeah, a lot of things has been changed there. But if it is consistent, then yeah, it is consistent. Then like yeah, it is. It's a good model for JAWS then. If you change the tweak, but I'm skeptical that it should be similar. Okay, maybe like we can change a bit. Okay, let's try to change something more. Okay, your rating is a number between 1 and 4. Okay, let's try to. Okay, I think this was better. So let's try to make it float then. Let's see what happens. Yeah, and let's see. Just a tweak. Yeah, these models are nowadays like they are optimized for this task. So it could be that it can give the same answer like even if you tweak it a bit. But yeah. Yeah, okay, it changed a bit now, see. So that's the point. But like, I was really surprised. I was thinking that the output would change a lot, but like, you know, it is nowadays trained for this task. So like changing prompt, you have to optimize it, but it's like if you just change few word or like something, like it might not drastically affect the performance. So like, Coin is very nice for this task. So that's what we proved. So okay, that's the point that I was trying to show. Like, you know, it should be very, you should be like, you should be working around in this prompt engineering thing. So you should be sure that, you know, the prompt aren't that bad. So you should optimize it a bit so that the model totally understand what you want to JAWS. So that's the point. So let's move on. So now this is the correlation in very small subset. So I want to try it on the bigger one because we have filtered the data frame where the humans agreed. So it was like 28 examples. So let's do it on the whole one. Okay, these are the cases where there was error. So let's. Okay, this one. Okay, let's see some error cases as well. So this is like human score 1, and this is like from the LLM. So there is like minor differences. For example, like 1 was given 2, like there is good justification, and like 2 was given 1. So yeah, it's like minor changes, not so big changes, because you can see from the table that they were correlating pretty well here. So it should be good enough here as well. So let's run the correlation between humans and, okay, I just copied from above, so it should be something like this. Yeah, so we can see that the correlation between LLM JAWS and the human data is also like pretty good. So yeah, it is the cases where it was excellent for human score, like it has been acceptable to LLM, so there have been minor changes, but as you can see that like there is 0 on the both side, so that means that there is no like flipping. For example, if it was bad for human, it is not excellent for LLM. So it is this is what it is shown here in the confusion matrix. Now let's try to run this for the whole set, not just for the small subset where the score was same for humans. So let's do it for all. So I'm using a library called it's like pandas parallel. So I want to show that like how scalable this is. So we have 6,500, like something 5,660 samples. So I'm trying to run it on 30 workers here. So look at the speed. So as you can see that, you know, this 5,600, it seems like it will take around less than a minute. So we can run 5,600 evaluations, you know, rows in less than a minute. So we can increase the number of workers as well. So you can make it 100 if you have like multi-core CPUs. So this is running on like basement in Simula. Something is burning there. But like, yeah, if you have like good resources or like access to API, so it can be done very fast, very scalable. So yeah, let's wait for this a bit. And also to be noted is that it used VLLM inference engine, so that's highly optimized. So it used query caching, so like, you know, it can do inference like with a really good speed. So it is like industry graded inference engine and open source. Yeah, you can also try it if you want. Yeah, almost at the end. Okay, now all the workers are like almost, they have completed their task. Okay, one green signal. Okay, more greens. Perfect, it's done. Okay, let's see like what was the output. Okay, this was like the question answers and stuff, and at this end we have LLM judge score, LLM judge output. This is one. So this is the output from LLM, and this is the score. So okay, let's see this one. Score 1, the first human data it gave 2. Score 2 is like the second human data, it gave also 2, and improved score is like the score from our LLM judge, it gave 1. So there have been differences here. So yeah, we can see a couple of examples. Let's see like 5 examples. And here like 4, 4, 2, 1, 3, 1, 2, 3, 3. Yeah, it's matching. So yeah, okay, let's try correlation. Let's try to compute this one. So yeah, correlation between okay, the second scorer. Okay, let's try with the first one then. Let's try the correlation between the first scorer, the first human evaluator, and the NR LLM judge. So it is 0.54. So the thing to be noted was the correlations between two human scorers were like it was 0.56, and the correlation between human scorer, like the first human scorer and LLM judge, was 0.54. So it's almost similar. So let's see the second ones. So it is also like 0.557. So it's almost similar. So yeah, also yeah, there are edge cases here a bit, but the scores are almost similar to the correlations between human scores. So that this kind of proves that our LLM judge, it is working very similar. It's giving very similar performance with the human scorers. Definitely, like human scorers are also not agreeing with each other, but like yeah, it's the same correlation. So that's what I wanted to show. Now, how can this be improved? Can we reach 100%? This is the question. So, for example, in this data set, like I showed that a bit of prompt tweaking, we could like change the scores, like correlations there. So, if we tweak it a bit, can we reach to 100%? So, not in this data set, because the theoretical limit or kind of the correlation that we saw, like we are considering human scores as gold standard here, and they are not correlating as well. So there is very slim chance that we will ever reach 100% here. So it's a very nice score that we got here. And also, like we can do lots of tweaking here to make it more consistent. For example, in this judge prompt, I think it was in Blatt's site that there was few short example. So we can give some examples. We can make it more aware. So we can say that, okay, this is how you score. So you can give some cases. You can just write that, okay, if this was question and this was answer, the score would be 2 or 3. So you can just put there in the prompt. So yeah, you can make it longer because the inference engine is optimized for this kind of thing. So if the judge prompt is same, the system prompt is same, like it won't impact there. It will catch this result. So the performance will be almost similar. So yeah, there can be optimizations here as well. So after okay, apart from that, let me see what we can do. Yeah, also one of the things that I could improve here is like we asked it to output in some word format. So this is like it's just text format, but we can use some strict format like JSON. So nowadays, this kind of model, they are very good at outputting JSON. So we can say that, okay, just output JSON with these keys. So it could have been like output JSON with 2 keys. One is score and another is justification. So it could have been done that way. So yeah, these are the improvements that we can do from here. Yeah, also I'll share this notebook with you guys. So you can see from the link. Okay, now I'm almost at the end. Let me see. Yeah. Okay, you can see this one. I think I should. Perfect. Here. So now to wrap up, we have seen that LLM judge, they can evaluate thousands of outputs in a minute. That makes this kind of evaluation very scalable. So you can use it in your own task. You can define rubric. You can experiment and play and figure out like how it can supplement human evaluators or annotators, or how you can benchmark with this kind of LLM edge judge systems. And another good thing is that it adapts to any domain or any criteria. Either it could be finance, healthcare, law, or education, or whatever domain you are using, you are trying to benchmark. And this makes them very flexible. So it can do like multimodal tasks. You can use image, videos, audio, whatever you have, given that the LLM, VLM supports it. And the good thing is that they also give very rich explanation, not just numbers. So you get scores as well as explanation there, although they can sometimes be very naive, but like that can make them very insightful. You can probe into like why the model gave that number or like that score. There will be some justification, text justification. So that is very good thing of LLM. And the best part is that pipeline like this, it already exists today. So we saw that like language benchmarking pipeline that Blair showed. So there are lots of libraries that are implementing this kind of things under the hood. So if you want to integrate into your thing, it's very practical. So you can just figure out what is suitable for you, and you can use this kind of thing. So now, I'm almost at the end, and I hope like this will give you some idea to think that how you can use like AI as the judge in your own work. So if you want to build trustworthy, reliable system, we also need trustworthy, reliable way of evaluating this AI intelligence. And it can be done with AI itself. So I truly appreciate the time that you gave here and organizers for organizing this great event. Thank you.
Thank you so much. We have time for one question from someone. Yeah, yes.
Hi, thank you very much. I would like to ask if in your experiments, do you get any insight or an insight about what's the effect or what's the preferred scoring scale? You showed 4 categories and it used discrete outcomes, results, 1, 2, 3, 4. But I wonder if you have seen anything about how it works, it performs when using other scoring systems such as 1 to 10, 0 to 100, or other categories. Maybe when you made that decision to use that, I know you took an example, but anyway, if you can say something about that.
I think the scores used here was very naive, so like the choice was very naive. So I think if I had to do it, I would do in a scale of like a bigger range, like 1 to 100. So it would be that would be a better choice. And also, for example, if you want to get multiple type of what do you call this? Like for example, if you want to benchmark for different, not just accuracy. For example, if you want to do it for safety or like other benchmark, so it would be better to have like separate prompt pipeline. So and like use larger range of scale. So that would be better. So instead of just using discrete number, just if you force it to output some float number in like bigger range, like 1 to 10 or like 1 to 100, and like explain it. What is the consequences? Or like if you just ask it to scale, I think there is no point. I think the good way would to be like if you it should understand the range. Like what is the difference between 1 to 10 and like 1 to 20? So like the rubric should be very clear. So if you do that, so I think it would do better instead of just asking discretely. So I mean prompting to make the rubric better. So it's kind of experiment. Also we showed that I tried to change integer from int to float. I think I changed that in my prompt, and the performance degraded a bit. That's what we saw. That's what I showed before. So it's kind of experimentation. So it might not be true for everything, like every data set, but I think it's better to just experiment and see what it happens. And yeah.